All right, well, welcome everybody here. We're going to focus a lot of time on Openscad tonight. It's a free software program, and it's very useful for when you don't need to, I find it useful when you want to make a plate or something, and you just want it to be dead on, and you want to be dragging circles all over. So sometimes programming makes it a lot better. And then if you like math, it's got it. Okay, good. All right, excellent. So let's go ahead. You'll stay on after class. All right, great. So now here's what we're going to do. I'm going to escape back off this, but I do want to go to Tinkercad. For people that missed, I want you just to see these new features, and I did miss one. Give you an idea today, there's the Tang child skull. A great, interesting story on that. They found the skull, and it's near South Africa. It's in South Africa. And for years, they always assumed it was a tiger that ate it. They knew it was, we died back then. This was, thousands and thousands of years ago. You got ate by animals. That's how you were a prey item. You were a lunch waiting to happen. And in many instances. And they thought it was a tiger. What they found out by looking at it and using a 3D printer to print out the skull, they realized it was actually one of the great African hawks. And so this was they figured out, 3.5-year-old boy that was eaten. And, or 3.5-year-old child. I'm not sure they could tell the sex of the child unless they can pull the DNA out and figure out the chromosome. If you go on there, you have to get the 4 parts, and we can print that out. So we're dividing it. I've already printed this part, and I left this part is printing. We'll have the next 2 parts. But let's go play with this. I'm going to hit Tinker this. For everybody that came in here, this is my delete example design. I go into design. That's where I go ahead and download. Let me just show you real quick a couple features that people that weren't here didn't see, and I really want you, because we're going to be making... here we go here. We will be making checkers, your own custom checkers. I made Batman versus Superman. People in Charlotte will see it tomorrow night. People in in Harrisburg already have. People in Raleigh will see them down the road. But it could be anything. If you got a logo. If you're a football fan, great. If you're a Doctor Who fan, great. Whatever. All right? But let's go through some of the features we use in Tinkercad. Just a quick review. These are not grouped together, and they're not grouped. How do I know this is not grouped? These 2 right here. What would typify that I knew that was grouped? That D and that red block. Somebody here, guys. Please, give me an answer. All right, we got some. All right, great. Riley, what do you got? They're different colors. Well done, everybody. They're different colors. Now, sometimes we want to group them. Sometimes we just want to select both of them to do something. And so let's say I grab this D. If I go anywhere on the D, I can move it around. Just a reminder for folks. And then the white corners allow me to change proportions. Right? And then if I click on this, hit shift and grab a corner. Let's go through here. That'll even make it bigger or smaller. All right? Now, okay? Now, what's great about this, I apologize, is sometimes I might put that D and I don't really have it lined up. And one thing I also want to do with this D is I usually want to shove it in. So I'm pushing it down a little bit. We definitely want this D to be in the block if we're going to print it out. If you have it on top, it won't print well. So a couple things we're going to use. I like using rulers. Put those far over to the corner for those who missed. It gives you a good sense of, if you click on anything, now I can change this. So I can change the height of this. And it'll be exactly that. Change the height of this. And it's now exactly that. All right? So that's the first good thing about a ruler. Also, and I didn't talk about this before, and this is what I want to talk about. This is one of the things I missed. If I go to turn this, if I stay on the inside of this, oh, come on. It'll go in big blocks. All right? That's in big sections. If I wanted to turn just lightly, I pull it to the outside, and I can do it by 1 degree at a time. All right. Let me Command Z and put us back to where we were. So, but how do I line that D up? Well, the good news is we've got these adjust. I'm going to go ahead and move these out of the way. Put that here. And I'm going to select Align. All right. They'll usually have, let me see here. There it is. There's little black marks that will help you line it up. Especially if I've got this, I don't think I have them both selected. Let's make sure we get them both selected. Now let's try that Align. Okay. Now when I put this here, see how this orange, I don't know if you can make it out, that will move the D. So now it's centered that way. And if I move this and move to here, now I've got it centered there. So it's a great way to center things, and going to be really important when you're making your piece to print out. We have 5 3D printers now. We're supposed to get another one in March, and I'm trying to negotiate a 6th one in March as well. So we're going to have lots. Science House is going to be getting some 3D printers. So we'll have plenty of 3D printers that you all can use and print things out. So there's an alignment tool. Let's look at the mirror. So you just saw the alignment tool on that. Real quick, the mirror tool, for those who didn't see it last time. So I'll move this over here. Well, let's go over here. Oh, come on, be that one. Now I can move them all over here, right? And so if I go over here to adjust again, I select mirror. You're going to see that there's a little red arrow that you put your point over. It's black to begin with, but see how this is going to flip it? And I flip it back. It makes the mirror image of that. Now, surprisingly, you can go over here. It'll sometimes pop out, and sometimes I think it's probably good to zoom in a little bit on this. Let's go ahead and you got to highlight. Again, I haven't grouped them. If you group them, you won't be able to adjust them. Once they're grouped, you can't adjust them that way. All right, so, and you can try it. If it doesn't work sometime, make sure you haven't grouped them. See how that keeps changing? See? Big B there, little b there. Not so obvious there. There you go. So these are all good tools. The little arrow that's red will allow you to flip things. Don't get the black one. That doesn't do you any good. All right. So there's the mirror. There's this. Let's go. When we do group them, a lot of times we group them to say put a hole in here. All right. So right now I'm going to click on this one and make it a hole. If I group that, not surprisingly, because that's how it's supposed to work, it just put a hole in there. All right, and now notice it's grouped, it's all the same color. So let's undo it. Make it leave that color. Okay. Now, one other thing you can do in here. The workspace, I guess 2 more things. I'm going through this really quick because we already did this last week, but I just want to review for people that weren't here. Get it. If I want to put a letter here, that's the classic. Now I can put it on this side by changing the workplace. And if I hit that W out here, it'll put us back. See, originally, if you bring that letter in B, it only wants to go in this way. By putting the workspace here, we can do that. Let me go around and I'll demonstrate it again. When I can turn the block if I want, I can just take that. I'm going to turn it just a few degrees. Because I didn't group it, it's there. Boom, see? Really didn't change anything, they're not grouped together. If I group it together though, watch it, group it, change degrees. Now when I change it, the whole thing moves. See that? And let's go to 90. All right, so just did a 90-degree change. If I tried to drop a new letter on there, say this C, it's here. I can't get it on that side very easily. So, I mean, I could tilt it and do things. What's easier is hit W, bring this up, put it on the plane. There it is. Bring another C over here. Boom, it goes right in. I can shove it in there a little bit. All right. Your ruler goes away when you do that. I should give you a heads up on that. Okay? The last thing I want you to see, let's get out of there. If you want to get it back to where you originally were, hit W again, just put it anywhere else. It'll be there. Let me go back up here. I'm closing everything up here. I'm trying to get where you can go. Here it is, import. If you go under import, you believe it or not, you can choose a file to import on this. I did not mention this last week. But you can go out, you can find either an STL file, that's the format we use with 3D printing. There's an SVG, that's associated, and we're going to get into Inkscape, we'll talk about that, but you can bring in your own shapes and sizes. So if you want to bring in your own logo for your checkers or something you're building, then get an SVG file and we can import it into Tinkercad. All right? So I really want you to realize there is a lot of stuff now we can do this. It's getting to the point where it's not a toy. You really can make things with it. Any questions now? Okay. All right then. We're set to go with Tinkercad. Let's go ahead, get out of Tinkercad. Let's go to Openscad. All right. That's what we're going to do. Now, we've talked, just showed you how to do those guidelines in SketchUp. I think SketchUp's great for architecture. I think Tinkercad is great for just getting something easily done. But if you do something with Tinkercad or SketchUp, say lining up holes, it can be pain and tedious. I think Openscad, which is also free, is a good option for you there. We're just doing this with high school. We're not doing it with the middle school folks. So here we go. Now, again, we're going to talk about what CAD is. We've been talking about 3D printers. It's just allow you to draw and design three-dimensional objects on a two-dimensional system, if you think about it. And, you know, dentistry, architecture, dentistry, now they're doing all the work on your mouth right there, which is pretty amazing to me. And we've done, we've done Tinkercad and SketchUp. And this is more the computer-aided design aspects, not the artist or fun stuff. Not fun is the wrong word, but, this is all very cool animation. This would be more CAD, where, hey, we're going to make something a very specific object. All right, and, Openscad is good for these things. It's less good for something like this. Okay? It's going to be good for doing CAD work, not so great for animation. I mean, you could, but it's not. It's not an interactive modeler. Openscad is not an interactive modeler. When I do Tinkercad and I pull it and I move it and I grab it, that's considered an interactive modeler. I can change it right before my eyes. All right, and that you see with the mouse. We use script. That's a lot like programming. And, you take complex 3D objects, combine 3D primitives such as a sphere and cylinder and cones, and math operations to make something very, very complex. And you can do that through addition, but you can also do it through subtraction, which you normally don't do in Tinkercad. And we also look at intersections. Okay, let's go ahead here. Making sure it's not apparent, guys. Sorry, we always want to make sure. All right, now, loops, conditional. So because it's like programming, you're going to have things on this in loops and conditional. If this is true, do this, which is kind of neat. You normally don't think of programming that way. All right. Also, if you're more of a math guy, I think this is good. And I think it's good if you say I got a 2x8 foot plate or 2x8 foot plate. I need 6 holes equal distance across the plate. Openscad is good for something like that. I don't think it's particularly good if you're trying to draw a gorilla. or make some graphic. All right, we got some people here with questions. All right, great. I just want to make sure I'm all set. Though you can do graphics. I mean, look at this. It's supposed to look a little bit like a spider, but it only has 6 legs. A spider would have 8. Obviously, this looks like a phone case cover. Here's another squid. So I don't want you to think Openscad you can't do creative things with. You can very much. But I think what is important is if we... And you can go out there and find Openscad stuff. So don't be afraid to print it. Don't be afraid to use it. What I just want you to learn different tools. So you pick the best tool. And if you go to college, you need to do it. One of my requirements, as much as possible, I try to get free tools. So that way I know everybody can have it. And it goes across platforms. This goes under Linux, Microsoft Windows, Mac OS 10. No worries, guys. So what I want you to do is go to openscad.org and download it for the Mac. Raise your hand once you've done that. Okay? So raise your hands once you've got it downloaded and installed, so that way we can be able to start here. And if for some reason you say, well, I can't install it for whatever reason, then raise your hand too, so we're not waiting on you, okay? Now I'm going to go ahead and... All right, let me pause. I'm going to upload mine and get mine set to go here. I'll go ahead and download it again. I have had it in the past. Let's go ahead. Go that. Download Openscad. We got most everybody's got theirs running. What I love about it is I love the free software. If anybody has a good book, G-code book, let me know. I know of none. I've been asking around. Okay, here we go. Hopefully in my lifetime. Come on. So I just went to openscad.org. Come on, Openscad, let's go. Bear with me, folks. Move this over here. There is Openscad. Yeah, I want to open off the net. Let me go ahead and put this back up here. All right. Here's the basic window of it. And I'm going to try to get this to hide down. Okay, let's go back up here. There it is. Download it. We just did that. I just installed it. This will open you up for Openscad right there. All right, and you get a window on both sides. One's going to demonstrate it, one you're going to write your code in. This is where you type your programs on this side. Right panel is where you're going to view it. All right, and then we can compile. So we're going to start off. I would like you to type in circle, parentheses, r equals 40, parentheses, semicolon. I'm going to lower everybody's hands. Go ahead, let me know when you've done that. And then hit compile. F5 will run it there as well. And let me go ahead here. So I'm going to type in circle, parentheses, R. You can imagine that's radius. We are talking about circle after all. And then we just do file. If you hit F5, there it is. Notice like C. In other languages, you got to have that semicolon after that. Okay. Let me know once you've got it so we can move on, folks. Folks, make sure you subscribe to YouTube. Also, I'm going to be there's a very good chance I'll be in Boston Wednesday or on a flight to Boston. Either I will have Carolyn doing it or I will record a webinar while in my absence. Okay? Now, this is how it looks like, circle with 40. I've got the X, Y, Z coordinates in mind, so that's what the difference was. Okay? Now, here's circle, and these are parameters, values you can pass through to them. All right? So there's your function, right, called circle, and here are different parameters. The argument is what you supply. So you could either do radius or you could use diameter. In this case, we're saying R is 40. All right? And this turning on the show axis can be helpful in seeing how your things are placed. Make sure that's on. It almost defaults to it. See, that's right there. So under View, if you go up to the top of your Openscad program, hit View. I've got show axes. If that's off, you don't see it. If it's on, it's there. Okay. And you can, you can click on it and manually turn it. Like, see how I'm turning it right there? This whole part is changing as I turn it. Okay. And then you can do things like, by looking at View, you can go up to and hit top, or you can hit, Command on a Mac. It'd be, you can choose different viewpoints basically off that. Top and bottom, 4 and 5. There's left 6. See how we're looking from the side? It's thin. We're looking right on the edge, so we'd expect that. And there it is. There's top. Just like a lot of programs here, I'm moving it back and forth. Right-clicking, you can pan it. You can scan in, scan out. There we go. All right. Would you all do that for me real quick, please? Raise your hand once you have it. All right, now. Well, raise your hands once you've got it, guys. So you go to the next one. So we go on the next. Okay, please. Again, this is another tool in your toolkit, guys. All right, how we doing over there? Brian, how we doing? Raise your hand and then we can go on, okay? Hopefully Brian will get his hand on there. We've got 86%, so I'm going to go ahead and move on. All right, now, we just played that exploring a few. Now, here's how you would do a square. All right, size refers to the length on each one of these squares. Center means you're at the center of the screen, or you can be at false means you're at the corner of the screen. All right, so let's try running that once. Go ahead and try running that real quick, and then play with it, make it false too. So here we go. I'm going to go ahead so I have my, do the same thing you're typing. There we go. Okay. So there it is. Kind of, let's pull this apart a little bit so it fit on there. All right, hit F5. There it is. If I make it false, what it looked, watch what it does. You all should be doing this as well. I'm almost always the guy that does that. The minute it shows true or false, I play with both of them just to see, okay, well, what does that do? There we go. Okay. Raise your hand if you got it. Daniel, if you got it. Brian, if you got it. Raise your hand. All right, excellent. All right. Okay, now watch what happens when we do this, which I taught this enough. I should have these slides memorized by heart practically. All right, if I do this, I make a simple typographical error, well, you're going to get something like that. You know, you're going to get an error, so that's what happens there, just like in code. All right? So, you know, watch for when that happens, as we all know as programmers, and there it is. All right. Isn't that a fancy way of saying, hey, you forgot to add a semicolon, and there's syntax errors. And by now, we've done some programming. As we do more programming a little bit later in, you're going to find the easy errors are syntax errors. You forgot a semicolon. You capitalized something when you shouldn't, or you made something lowercase when you shouldn't. Those are easy to find. It's the logic errors that will drive you to being very frustrated, where the program runs, but it's still not doing what you want. All right, let's talk about this function, translate, and what that really means. And go ahead, let's type out the code, run it, and then let's talk about it, okay? Again, we can move this out a little bit more so it'll fit in there. Okay. So translate 20, 0, circle 0. Try experiment a little bit. If you did this, what's it going to do? See, that's coming out of the z-axis. Notice that's but now behind the cross there. Go ahead and play that a little bit, guys. Raise your hands once you have it. All right, excellent. Transformations refers to translating, shifting, rotating, scaling, bigger or smaller, and mirroring, reflecting of shapes along an axis. In Openscad, you simply put the transformation expression before the expression that forms the shape. So all we're saying is if you're going to move it or shape it, you put that first and then you make the shape. All right? Multiple transformations can be applied to a single shape. So let's look back up this. So we did translate this circle, which you would think it'd be circle then translate, or at least to me I would, but that's not. I'm not the mathematician, these folks are. Translate shapes along an X and Y or Z axis. That's what that is doing. And we could see the difference on the Z, which isn't always. X and Y are easy to see. You know, X is along this axis here, Y. The Z, it's getting it up and down there. All right? So that makes for doing all kinds of funky stuff you wouldn't think. So there we got translate a circle. Look at this case. The z-axis is up right here. That's the negative z-axis. And you could start red and you can change that. So these are two different translations there. Okay. How's my pacing going here, folks? Let me launch this real quick. It's that time I always like to know. All right. 71% voted. 86. All right. I'm close the poll in 3, 5, 4, 3, 2, 1. Share results. Sounds to me like my pacing is A-okay for you guys. So let me hide that. I usually will forget at halftime. All right, so there we go. Now, needless to say, you can make two circles on the same axis. Why don't you go ahead and try that? You know, it's not a bad idea in the beginning to type the whole thing out. I have found that if you just cut and paste, you really don't get that much out of it. Let's make this 30 up here. I think that's what they have here. 30, 0. My question for you is the top one on the right or the left? Think of your X and Y coordinates. That should tell you right there. Let me move my, let's see, right there, I've got it. Gotta make my radius a little bit smaller. There you go. Again, like we've been doing, raise your hand once you have it. All right. Now, we got that. So we're able to add multiple items that way. And if you think about it, rotate is just like on an airplane we've done. So you rotate 45 degrees, 0, 0, square, size 60, center is true. So it's going to tilt it. And it's going to tilt it along that the x-axis. Excuse me. So let's go ahead and try that one. And play with it. Change it from there. So we're going to get rid of that. I'm not going to really save these. Personally, I like I said, I type them out so that way practice what I preach here a little bit. So I got to change my viewpoints here. Let me go ahead and do that. If yours doesn't look quite like what you think it should, just remember, whoops, you might need to change your viewpoints, all right? So I'm playing with all these different viewpoints of view, and then you got back, diagonal. That's a nice one right there. Okay. Again, raise your hand once you have it doing that. All right. We're getting there. Now, if that was rotate that along that square, let's rotate, you can do it Y. This is along the vertical axis. Your log here is the x-axis. So you got all kinds of different ways you can play with that. Okay. And here's along the z-axis, the whole thing's going to tilt. So it rotates along those axes. All right. Any questions about rotating? Go ahead and play with that. Rotate them through, everybody. And yeah, you can do things where you animate. You can do things with this, in case you're already wondering that question. So that was rotating like this. So I made another one. So it rotated. We've got them turning that way. And not surprisingly, you could do, which I'm going to do real quick here. Kind of gives it a cool look here if you do this. Or at least I do think it's cool. Look at that. Slicing things all through it. So raise your hand once you have that done. Yep. Garen says you can add color to the shape. Absolutely. Excellent, Garrett. So Garen found that. And then color name before the function. So you can add color to this as well. We're going to get to that in a little bit. And they've got a wiki on all these different things as well. So feel free that you're going to get that. Okay? All right. Let's... Mirror does just that. It flips something over its axis, which is a kind of a one in whichever axis you want it to flip, which is kind of cool. So there's a square, and then you can mirror it. All right. So let's go ahead, try that one out. Nice. That makes me feel really great that it's not. Oh, I saved it in the wrong place. That's why I'm running it off there. So let's do it there. Okay. Oh, let's go ahead. I'm sorry, I meant to put that up there for let me go back over here. Oh, man. Did not want them to do that. I lost it for some reason. We'll try it again. While it pulls out there, let me go ahead and hide all this up. There's my dimensions. All right, here we go. There we go, 60, comma, center equals false, semicolon, and then, so that would run, so right there you get it again, so you'd see there's first window, right? Let me go ahead and make this a little bit bigger so you can see that. Okay. So I'm going to go ahead and put it right there. Then, using the same thing, I'm going to mirror it. All right. And then I'm going to do okay, 1, comma, 0, comma, 0, bracket, square, size, whoops, equals 60, semicolon, center, equals false. All right. And there's the mirror. And it went all the way across because of the way I rotated that apparently. Okay. See, I got on this side, and now this side. If I don't have that line, let me see if I can do this one. I can comment it out. See how there's no mirror on this side of this? Let me make that bigger for us. Now I'm going to take the comment off. Whoops. I always want to do that, sorry. There it is. It's mirrored. Okay? Raise your hand once you have that. All right, excellent. All right. And then you can scale things along a certain axis. Where so we scale, that's 2 to 1 to 1, center true. It's going to scale along this axis. Now, surprisingly, you can go the other way where you scale 2, 2, 2, and you make the whole thing better. All right. So we've done translate, rotate, scale, mirror. Let me go, I guess we'll do, since we haven't done this, we'll go ahead and do, we've done all the others, we'll do scale too. So let's just go up to the square right here. I'm going to type scale, parentheses, whoops, parentheses, just because of time here, constraints. I'm going to kind of pass things up here. 2, comma, 2, comma, 2, bracket, parentheses. And so one will be bigger. See, there's a scale here. It's thinner and thicker here. All right. Okay, so those are the different transformations you have. And then you can do polygons. And that's multiple points here. You know, with what your knowledge of looping and stuff, you could really start making some really neat stuff. And then we have different paths. And we start talking about spheres and things. So we'll get to polygons. We'll start that Wednesday. It's 5:56 right now. Any questions before we call it a night here? Remember, if you're in Charlotte, you have lab this week. If you're in Charlotte, you have lab tomorrow. Okay? So make sure you come. We're looking forward to having you. So, any other questions? All right, then. That's what we're going to stop. I'm not going to go on any farther from that. I think you can kind of see where we're going to. But that should give you a pretty good start of things. Okay? If you don't have any questions, you can leave. I'll hang on for those that might have a question or two. Okay?